12.7 increasing and decreasing functions. Um, Actually, increasing and what is the meaning of this? How do you feel this increasing and decreasing functions? I think this word is a bit heavy. We put curve, increasing and decreasing curve. So, for example, if I draw like this, so this is the curve. So you can see that from here to here increasing, and from here to here you can see this is decreasing, and from here to here increasing again, and from here to here decreasing. So I show it by visual inspection. Now what do you think about the gradient? You can see the gradient is always positive up to here. Then gradient is from here to here in this interval negative. In this interval it is positive. Again from here to here it is positive. And from here to here it is negative again. Sometime if you have flying experience, right? So gradient is 0, take off, right? Then again 0, then further take off to 33,000, then go certain inches, then start decreasing. But this is not the plane, this is parachute jump. No, this kind of very slight slope. Right? So if you can explain uh, by looking at the gradient, whether positive or negative, then you can express whether function is increasing or decreasing. Also, you can see this observation as well. When so this is going to x direction. When from here to here, x value increasing. What you can tell about y value? Y value is always increasing up to here. And when x is increasing, assume that you start from x value from here. Again, from when you go here to here, x value is increasing, you will see that y value is decreasing. This is another observation you can see. When x is increasing, y also increasing, like this. X is increasing, y also increasing. Then this is increasing curve or increasing function. And x is increasing, y is decreasing, then this is decreasing curve. So it's very simple. So this is another observation, but simply we are working with the gradient by looking at. Now about this one, what you can tell about y equal x square. So you know that this is the curve. From 0 to here it is increasing. From here to here it is decreasing. So you can look at the gradient dy by dx. Here gradient is, you can see, negative. So when you get dy by dx, this is 2x. Right? So let's say this is y again, y equal 2x. So this is line. So like this. Now this is dy by dx line. You can see here all the values, y values are positive. Dy by dx, I'm not talking about the curve. Here all y values are negative. Can you see that the negative gradient? Let's consider this example. Y equal x cube 3x square minus 9x. Now we want to find, we are not going to draw this one. It will take time. And I want to find the area that this is increasing or decreasing. Let's say I want to find the area, decreasing area on this curve. Decreasing area. So this curve go like this. I want to find the area. I'm not sure, like this. Somehow there are increasing and decreasing area in this curve. So we want to find the decreasing area. How do you find the decreasing or increasing area? By looking at what? Looking at gradient. So this curve is not that important. I am worried about the dy by dx, gradient one. So I'll find gradient. Dy over dx is, this is 3x square, this is 6x, this is 9. Now I am going to look at on this one. So if it is decreasing, if the curve is decreasing, then dy over dx should be less than 0, right? When you look at this one, so this is positive, right? So dy by dx greater than 0, this is negative. Dy by dx less than 0. Now we want to find the negative area. Now we are not worried about the curve, we are worried about the gradient curve. This is, so I will write this is again y equal 3x square plus cx minus 9. Now okay, I will stay with this one. Dy by dx, what is dy by dx? 3x square plus 6x minus 9 less than 0. It means y less than 0. If you consider this curve y equal, this is a quadratic curve, this is a cubic one. So 3x square plus 6x minus 9, right? This is less than 0 mean, what is the meaning of this one? This is equal to this, y less than 0. Basically you need to find, when you draw this equation y equal 3x square plus 6x minus 9, whereas the y value less than 0. Okay, now we'll simplify this one. We'll draw this curve. How do we draw this curve? So quadratic equation, we have to draw this one. A greater than 0, then it has minimum, and when x equals 0, y equal minus 9, then y equals 0, 3x square plus 6x minus 9 equals 0, then this is going to break out. I can divide by 3 all the curve, 3x square, 2x minus 3 equals 0. This is x plus 3, x minus 1 equals 0, in x equal minus 3 and x equal 1. right? And then we have to complete the square, and but I will write roughly. Uh, so this is x, and x equal 1, 1 crossing point, other crossing point is 1, 2, 3, minus 3, and this is going where? Minus 9, 0, minus 9 somewhere, right? So this kind of curve. So this value is minus 3. This value is 1. Now, when you look at this curve, right, which area you can see y value is less than 0. So x is as it is on the line. So if you take this point, if you pick up this point, x is positive or negative. Sorry, y is positive or negative? Positive. Positive 5. If you select somewhere here, still this is positive. If you select this point, right, y value is negative. And if you select this point, y value is negative. If you select this point, y value is not the x, y value is negative. I'm not worried about x. And this is y value is 0. That's why we work out this one. This is also y0. And from here, y value is again positive. If you select this point, it is positive. Now you can see that from here to here, minus 3, x and 1. In this interval, y is less than 0. It means this is gradient curve. You will get a negative gradient in between here. So it means in this curve, minus 3 to 1 area, you will find a decreasing pattern or decreasing shape. Now I draw this curve, proper curve. It's going like this. Can you see from here to here and up to here? This is x equal minus 3. This is x equal 1. This gradient is, can you see the negative? If you draw a line, tangent, you can see all are negative tangents, negative gradients. So you can see that yeah, this is up to here. So this is 1. This is x equal 1. Up to here, they all negative gradient. After that is positive. Now you can see, can you see this blue curve? This is the gradient curve. Can you see this gradient curve? Y value is negative. It means the gradient curve negative minus 3 to uh, if that's x, I will take if that's x is 1. So from this area you can see that this green line is negative. So the slopeness we decide by looking at what? Gradient. It's like you can tell about my dad by looking at me. So likewise, you can tell the slopeness of this curve uh, by looking at the gradient curve. So this is negative gradient. So you can see that value is negative. Assume that if you don't draw this one, how do you do? So now, finally, what is the decreasing area? Decreasing area is this one, minus 3 greater than, what is this value, x less than 1. So during this area, the function is decreasing. Now assume if you don't have this one, so then how do you do? So then, so you get dy by dx, then dy by dx is 3 x plus 3 x minus 1. So when you take dy by dx equals 0, you can identify x equal minus 3 or x equal 1. So you can identify 3 clear areas. I'll take the, so one area is 1, 2, so one is 1, other one number is minus 3. So you can identify 3 clear areas, this area and this area and this area up to positive infinity. So if I write this one, how do I write? X less than minus 3, minus 3 greater than x greater than 1, and x greater than 1, or uh, uh, yeah, x greater than 1. Or you can write 1 greater than x as well. Now we differentiate, and then we get dy by dx. So you don't need to come to up to here, you can do from here. That's fine. I will. Okay. Now take any value from this area less than minus 3. Let's say x equal minus 10,000. So I'll put minus 1,000 here. Can you see? I don't need to write minus 1,000. Right? When I get minus 1,000, this is 3 times what is this value? Minus. What is this value? Minus. Minus 9 minus is positive. If I get a value in between this area, 0, this is minus 1,000 equals 0. X equals 0, you will get this is 3 times 0. This is positive, 0 plus 3. This is positive and this is negative. It means when you multiply negative. And in here, take x equal 1,000. Is it less than 1? Yes. Greater than 1? Yes. So 3 times 1,000 plus 3 is positive. 1,000 minus 1 also positive. Positive times positive, positive. So I didn't touch this curve anything. So I clearly identify 3 areas by simplifying like this. And then I will sub some values and then check. Then I found out this is negative. So what is this area? When you put x equals 0, minus 3 greater than x greater than 1. Instead of applying here, you can apply here as well. Minus 10,000. Then you have to do a calculation to get the answer. If you use with this one. But somehow we have to come to this level. Why? Otherwise, how are we going to identify the three areas? If I couldn't factorize, then I couldn't find the three areas. Then what we have no options. Then we have to go and draw the sketch and see. So I wrote the definition in the book. The function f(x) increasing on the interval a b if f dash x greater than or equal to for all the values of x such that ax. Now the function f(x) is increasing on the interval. Function or curve can increasing and decreasing. So out of that we are telling we are taking an interval. What is that interval? AB. So AB. Is it a closed interval or open interval? Closed interval or open interval? So what is the meaning of closed and open? Now you can see, if you see this one and if you see this one, so this is also referred as a greater than x greater than b, and a greater than, now you know the meaning. If you write like this mean with the square bracket, so a and b include. So when we select the interval, we have to pick up including a and b. But we only discuss the increasing or decreasing within that interval, but we disregard the equal sign. Let me tell it again. I think I confused you. When you consider A and B, let's say 3 and 4, during this 3 and 4, function increasing or decreasing. So we have to consider in this interval. So 3 and 4, the function, let's say, increasing or decrease. Okay, let's say function is increasing. Then what we have to show that 3 and 4 with open interval in between this f dash or the gradient has to be greater than 0. That's all. Let me take another number. So I want to show that between 3 and 5 this function is increasing. Then I want to pick up the interval, this one, open interval, 3 and 5. So 3, 4, 5. Then this is going to be 3.5. This is 4.5. Now you can see here when this is 3.1. Okay, we'll come to here. This is 4.9. 4.9 and in between 5. Then when you take again 4.95 and in between 5. Then 4.96. Okay, 4.995 and in between 5. Likewise, we will never reach 5. In between, if you show me any number, last number, I'll show you another number next to it. And this is ongoing. So this is one requirement. It's too technical. Just forget it. Leave it. But when you write the answer, you have to answer in this format. That's all basically. Only thing you need to answer in this format. For example, so we found out this is decreasing, right, in this interval. the function fx is decreasing on the interval uh, minus 3 and 1. See, close interval I put as f dash x less than or equal to less not equal less than to 0 for all values of x such that 3 minus 3 greater than x greater than 1, or instead of that you can write simply minus 3 and 1 open interval, or you can write like this minus 3 greater than x greater than 1. So same as you can tell that the function fx decreasing on the interval a b if f dash x, so this is greater than or equal to, that is positive, and negative has to be less than, for all value for all value of x such that a x b.